This lesson will focus on prime numbers from the broad general education. A prime number is a number which can only be divided by the number 1 and the number itself. It only has two positive divisors. The first prime number is the number 2. Therefore, 2 is the only even prime number, as all other even numbers can be divided by 2. Example 1. List the first 8 prime numbers.
In our first example, we're looking to list the first 8 prime numbers. So, we already know that the number 2 is always the first prime number. So we'll start with that. Now for every prime number, we're looking for it to have two positive divisors, the number 1 and the number itself. So the next number after that would be the number 3. That can be divided by 3 and 1, so that is a prime number. We know that any other even number after 2 is not prime, so therefore 4, 6, 8, all of them are not prime. Let's check 5. So 5 can only be divided by 1 and itself, so there's 5. Then we go to 7, 7 and 1. Then we go to 9, 9 and 1, yes, however, it can also be divided by 3, so that makes it not prime. We move on, we have 11. We move on from that, we have 13. We move on from that, technically we have 15, but because we know 15 can be divided by 3, it can be divided by 5, that rules that out. Then we go into the number 17, and then the number 19, and those are your first 8 prime numbers.
When a number is not prime, it can be referred to as composite. If a number is composite, it can be expressed as a product of prime numbers. This can be called prime decomposition, as we are decomposing the number down. Example 2. Find the prime decomposition of A, the number 24, and B, the number 50.
Prime decomposition on is the number 24. Now, when we're doing this, it's useful to use what we're going to call a factor tree. So, to do this, we're going to look for two numbers that multiply together to give me 24. So, there's lots of different combinations that we can use. I always just try and use the easiest one that I can think of, so therefore we know that 2 and 12 give us that. At this stage, we're looking to check if either of these are prime numbers. Now, we know that the number 2 is a prime number, so all I'm going to ask you to do is circle that, and that means we're going to stop there on that branch. If we move over to the next branch, the number 12 is not prime, so we need to break it down to try and get prime numbers. So let's go again, and that's going to be 2 and 6. This is prime, so we circle that. The 6 is not prime, so therefore let's continue to break it down. That will be 2 multiplied by 3. We already know that 2 is prime, so we're circling that. We also know that from the earlier example the number 3 is prime, so let's circle that. So to write your final answer, we have 24 is equal to 2 multiplied by 2 multiplied by 2 multiplied by 3. Now an easier way to write that would be 2 to the power of 3 multiplied by 3. Okay, in this example we're starting with the number 50. So if we begin with our factor tree, this time rather than using our number 2, let's choose something else. So two numbers that multiply together to give me 50, I'll go this time with 5 and 10. I'm checking to see if either of them are prime. I know that the number 5 is prime, so I will circle that and I stop with that branch. The number 10 is not a prime number. We know that because it's an even number, and the only even prime number is the number 2. So now we look to break this down, and now we'll go with 2 multiplied by 5. From the other branch, we know that 5 is prime, so I will circle that. And then I also know that the number 2 is prime, so I will circle that. So we write our answer together now. 50 is equal to 2 multiplied by 5 squared.
Example 3. Write the number 81 as a product of prime factors.
Okay, in this example we're asked to write the number 81 as a product of prime factors. Now this just means the exact same thing as prime decomposition, it's just been asked in a slightly different way. So let's begin with a tree. Here we have 9 multiplied by 9. Now I check, 9 is not a prime number, so I'm going to continue on. I break the number 9 down to 3 multiplied by 3. Now at this stage we know that the number 3 is a prime number, so let's circle. And we'll deal with this other branch. 9 gives us 3 multiplied by 3. Again, we will circle. And now we're going to write our final answer. So 81 is equal to, now we could write 3 multiplied by 3 multiplied by 3 multiplied by 3, but in a neater way, we're going to write that as 3 to the power of 4.